Hello everyone, I'm Lee. In this video, we're going to revisit the address book application we used before. This time, we're going to change the implementation of entry list. For the previous two versions, we use arrays to model entry list. We used the dynamic array and static array, and we compared those two. But either one, they're not good for very dynamic list. So think about it. Static array has to determine the array size at compile time. Dynamic array has to determine the array size at runtime. So at some point, you have to guess the size. The advantage of dynamic array is if the size is too small, when the needs come, you can still grow the array, but we know the operation is pretty expensive. You have to copy over the whole array to a new array, then delete the original one. So it's an expensive operation. For a very dynamic list, we can use linked list to implement it. So this is what we're going to talk about for this week, how to use a linked list to implement a list. Again, we're going to keep the public section unchanged. So this way the client code doesn't need to be modified. So we're going to totally change the private data member. So let's see. So first of all, for linked list, it's a bunch of nodes linked together. So let's take a look at a node. In the node, we have the data, and we have a pointer to the next node. We call it next. You see, it's a recursive definition. So we are using this data type while defining this data type. So we will talk more about the recursion next week. So let's see. So node is used to hold the data. So here's the data, and here's a pointer to the next node. And we have a constructor for this node. Say, if they give me a data, I'm going to initialize the node to hold this piece of data. So a data, we first get the email, then we set the data for this one, then we set the next pointer to no. Okay, so that's a node declaration. And for linear linked list, so we only need to keep track of one thing. Where is the first node? So this head is a pointer to the first node. If we keep track of where the first node is, we know where is the second node, because next pointer will tell us. And then if we know where the next node is, where the second node is, the second node knows where the third node, etc. So you get the idea. It's linear linked list. They're all linked together. So that's for individual node. Now let's take a look at the implementation. How do we implement that? Let's see. So let's first look at the constructor. Head equal to no. That means at the beginning, when we first create a list, we don't have any items in it. So unlike in array, even if you have anything in this, you have to allocate that chunk of memory first. Either allocate it at compile time or runtime, but you have to allocate a chunk of memory. But with linked list, we don't have to allocate anything now because we have an empty list. You simply say head is not pointing to anything, equal to no, and size is 0. And similarly for this constructor, we did exactly the same thing. Initialize head with no and the size with 0. Then load the address book from the file. So, and before we look at the destructor, let's take a look at how to add something to the linked list. Let's see, add entry. For this add entry, when we add something to the array, we say append something to the array is the easiest, the most efficient one, because you don't touch the existing entries. You just append it to the end. But for linked list, if we want to append something to the linked list, and with our current implementation, we only keep track of where is the first node. You have to traverse all the way to the end of the linked list, then link the new node to the end. So that's not efficient. So instead, we are going to insert a new node to the head of the linked list. So let's take a look. So we first create a new node. using this data. So we create a new node to hold this data. Then we insert this node at the beginning of the list. How to do the insertion? You simply set a new node next equal to the head. So, and then head set to this new node. So by doing those two lines, you just insert the new node at the beginning of the list and remember to increment the size. So that's about add entry. And now let's take a look at how to print all and how to traverse. So print all requires you to traverse the linked list to print every item inside the list. So let's take a look. Remember, we use an array, we use a running index. We initialize the index with 0, then we keep on incrementing it. Very similarly, we use a traverse pointer here. This is a temporary pointer. We cannot use a head pointer to traverse because head pointer is important. It's used to remember where is the first node of the linked list. If you use a head pointer to traverse, you forgot the head. Then you can never get back to the first pointer, the first node of the linked list, which means you lost the whole list. Okay, so let's see. We use a temporary pointer current, and we initialize current with head. That means we start from the beginning. That means at the beginning, current pointer is pointing to the first node of the list. Then you access that first node. Then you display it. Okay, then you update current pointer to current next. That means it will point to the second node. Then you access it and you keep on going until you say current means current not equal to no. That means you still have something to process. When current is equal to no, you get out of the loop. So that's how you traverse the linked list. You use a temporary pointer to help you, and you initialize with the head, then update it after each iteration, then test, are you hitting the end? If current equal to no, that means you're hitting the end. Okay, so that's how you traverse the linked list. Now let's take a look at the get operation. So the get operation means if I give you an index, you should give me back the entry at that position. So this is similar to the array implementation. And now let's see, we have a pointer used to traverse the list. We start the pointer with head, then we do the loop. We keep on advancing the pointer. So you start from head, then the first iteration it will point to the second node, then the third node until you hit the index. When you hit the index, you know current is pointing to the data you want to retrieve. This is how you do it. And you see, unlike array, when you do array, you just get to that position right away. Remember, array is a block of memory, and if you know the index, you can just jump to that position. You don't need to traverse. So this is the performance penalty for linear linked list. To access individual element, it's much less efficient than to array. But the beauty about linked list is it's very dynamic. We don't allocate memory until we need them. We only allocate memory in the add function. When we need to add some data, we create a node. Okay, so that's the get function, and the search entry is very similar. You can use some pointer to traverse the list and do the comparison to determine if the searching is successful or not. Now let's take a look at the destructor. So the destructor gets invoked when the lifetime of the list is over. We know we have to traverse the list and deallocate everything because every node is allocated dynamically. So we use the temporary pointer to traverse. While head is not null, we set current to point to the next one, then we delete the head, then we reset head as current. So try to follow this code to see what's going on there using paper pencil. And for the test address book, we don't need to change anything because we only touch the internal implementation of entry list. So here we just add the memory leak detection tool there. Thank you.